What are your kind of first thoughts on the topic of SIL certification?
Sure. Let's just get the elephant in the room right off the bat and get
Yeah,
everybody paying attention. Um, so you're at a Brownfield site and you don't have any certified stuff there. Should you add some? No. Could it make you less safe? Yes. So I'm not telling, so, just think about it. You're going to go to the plant manager and say, we need to rip out every instrument and a safety function and replace every transmitter and valve because we don't have a SIL sticker. Um,
yeah,
they're probably going to give you a very strange look. They're going to say not no, but
yeah,
some other expletives about we're not doing it. And so it's a common misnomer. Everybody just kind of thinks at this time that I have to use certified widgets, and that's not the case.
yeah,
I'm very much a keep it simple, stupid guy on functional safety, and that kind of be the theme for the day. Um, it's not about SIL calcs to the 8th significant digit. It's not about the world's most perfect SRS. It's really about the right instrument for the right application,
yeah.
testing instruments, finding problems, fixing problems. Although this stuff's a little bit of an aside. And the certification stuff is just kind of muddying the water.
Yeah. And by Brownfield
So,
site, just in case, because we got people from all over the world on this particular webinar. Just in case you're not familiar with that term, that's basically an existing site that doesn't, it's not a capital project where you're building something brand new today. It's kind of it's probably been there for 10 years or maybe longer or whatever the period is. So that's what Mike means by the Brownfield site.
and a capital project's a different
Yeah,
conversation, right? If I'm putting a new unit at an existing plant
yeah,
in Mike's keep it simple, stupid approach, I'd go with what you have and I'd not do the certified.
yeah,
If I've got a brand new plant from the ground up and you want to go certified, you could. That's an acceptable design option. It's just increasing your costs. You're doubling up stores and some
yeah.
other things that we'll talk about that might be surprising to the community about. Are those instruments really different, or are they just the
Yeah,
same device that you doubled up in stores? You paid a little extra money for a sticker and an FMEDA, but they're the same thing?
yeah.
Yeah.
And maybe we ought to make it clear at the outset about whether this topic was about just field devices or logic solvers. We're really talking about the field devices in this
Yeah,
conversation.
logic solvers to me, I don't think you want to be in the general purpose PLC world and claiming that it can meet a given performance, a
Yeah,
given PFD average. If you look at the requirements for general purpose stuff and what you've got to do that, it's very onerous.
yeah,
And if I even think back to S84, so 84 is the year the S84 committee started, 1984.
hmm,
The genesis of that was new technologies. If I was doing hardwired relay magic with a pressure switch to a relay to a valve, that's very simple technology, it's been around forever. Failure rates were understood and well known. And all of a sudden, you had the PLCs coming out, and there was significant concern. Are we making things safer by applying the new technology, or we're making things less safe because we've got a complicated device with printed circuit boards and software in there, and do we really know how it's going to fail? And so that was the genesis of the S84 committee. It was all around logic solvers. So at this point in time, I think logic solver technology, SIL rated stuff has gotten really well. The diagnostics are in there to make sure that when it's broke, it knows it and it has secondary means of de-energization. So I think logic solvers, you really, 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 really should stick with something certified, SIL 2, SIL 3 related
yeah,
for your facility. And we get more into the collection of data and other things later on, you'll see that it's kind of a violation of laws of physics for you
hmm,
to collect enough time and service for those things to get a number. Um, there was actually a war story. So way back when there was a ISA class, ES35, and it was all about the logic solver, and it was the Markov modeling of the logic solver. They don't offer the class anymore. And I was taking it probably 1997. I think I was probably sitting in there taking this class, and there was two folks from a oil and gas company in there, and they had some general purpose PLCs. I think it was Modicon 984s, And that's what they used for all their heaters, and that was their shutdown logic, and that's what they'd done. And they were doing some type of testing on them, making sure they're cool. And they got very rambunctious. Their last test is they somehow exposed the motherboard, and they took a pair of needle nose pliers, and with outputs energized, they physically ripped the processor off the board. Why? I don't know, but they did. The outputs didn't change state. They were in shock and awe, and they all popped in ES35 to learn more about logic solver failure rates and whatnot. And it goes back into, it's designed to run forevermore, not to know it's broke and bring you to a safe state. So, so logic solvers need to stick with the certifieds.
Yeah.
We could probably do an entire session on that one if we wanted to.
Yeah, I'll do a couple of slides just to say, what are we talking about? We're talking about either SIL capable or SIL certified devices, depending on which terminology you use, is one option, and the other option is prior use. So the SIL certified option, everybody will be familiar with SIL certificates. This is one example on the right-hand side. It's not picking on any specific manufacturer or third-party provider of certificates. But I wanted to make it clear at the outset that certification companies assess devices against 61508 requirements, not 61511, and then they assign what I'm calling a theoretical SIL capability. And that may or may not, and it depends very much on the certifier, include some assessment of proven in use, which is different from prior use. And we're not going to talk about that today, but that's where the manufacturer looks at their returns and they say, okay, we've had so many returns of this, whatever it is, device. And based upon that, we'll check that against a theoretical failure modes and effects analysis, or FMEDA, if it includes diagnostics. So proven in use and prior use are different things. Proven in use is very much manufacturer oriented. Prior use is the user making an assessment, and we'll get to that in a second. Second point there on the screen is the word certification doesn't appear anywhere in the standards. So that's a kind of an industry term. You won't find certification as a message in 61508 or 61511. The word assessment is used, of course, and certification really comes from the companies that want to promote certified devices.
And I'll make a quick comment on that, proven in use.
Yeah.
So if I have a widget that costs $100 and it breaks, am I sending it back to the manufacturer, right? It's probably just going in the trash can.
I was going to make the same point, but I thought I'd tee you up for it.
It is what it is, right?
Yeah.
So it's got to be expensive enough that it's getting concerning to the site. They're spending a lot of money on replacements before it maybe percolates back to the manufacturer. So
if it's a solenoid, forget it. It's not coming back.
Yeah,
if it's something that's $10,000, maybe, yeah. If it's an instrument, yes, no, but difficult. Depends on the type of instrument. So proven in use and prior use, different things. Then the second point I wanted to make before we kind of get into the meat of the presentation is just reiterate the prior use. I'm not sure the picture is relevant, but prior use is a documented assessment by the user. So the user is verifying the device is suitable for use in a safety instrument system or an application based on previous operating experience in similar operating environments. And there's quite a lot in that whole thing, and we're gonna get into that during the presentation.
Yeah, as a teaser for what we're going to talk about, everybody thinks prior use is too hard. It's impossible. I can't do it. So they're just going to fall back and buy a certified thing as I don't have time. This is too hard. It's impossible. We'll never get there. Yeah. And so they're taking the easy way out, they think, and they're also thinking that it is a conservative and safe route. And the prior use route is relatively simple and straightforward. And it's got overall cost savings connotations for your entire facility because now you can become data driven. And we'll do some ROI calculations at the end of this, kind of showing what If you just get data out of instruments you're testing, one, it'll support prior use, but more importantly, you can potentially go to your boss and say, hey, look, we can extend test intervals across the board for everything important to the site and start saving significant money. And all of a sudden, you're a functional safety compliance driver. Instead of telling your boss that, hey, we're not going to blow the plant up if we do this, or we're not going to go to jail if we do this, when he's going to look at you and say, we've never blown the plant up. Nobody's gone to jail. What are you talking about?
Mm-hmm.
And you're not going to get any traction. Now you can say, hey, we can save some money. And oh, by the way, do some of that compliance stuff.
Yeah.
Make us safer.
Yeah.
And now you might get management's attention, and you're happy because the functional safety stuff is going in and you've got KPIs going. Management's happy because they're saving money. It's a win-win. All's great and wonderful in the world. So this prior use is not big, bad, and scary. It's actually relatively simple.
Yeah, and we'll see during the discussion that we're going to go and elaborate on that a bit more. So I'm going to pose the question. So we've got maybe 3 or 4 questions. I think it's 4. There's every possibility we might not get through them all. so if we don't, we don't. But anyway,
minutes in, we'll see. Yeah.
So edition 2 of 61511, we're talking about 61511, the process industry standard. I think most people on the webinar today will be familiar with that standard. If you're not, then come on one of our courses. It emphasizes managing actual performance of an SIS over its lifetime rather than a one-time PFD calc. So we're all kind of familiar with PFD calcs or even PFH, but so the question here is, how do you think this shift towards ongoing performance metrics affects the long-term validity of relying on SIL capability certificates? Bearing in mind that it's really important to understand that SIL certificates aren't based on prior use. So proven in use, maybe, and that's not always the case, by the way. There are a lot of certificates out there that don't even look at the manufacturer returns. But prior use, definitely not. They're not based upon prior use because prior use requires the user to present the evidence.
So I'm a picture person,
Yeah.
and what this is a figure out of 61508. Like John said, 508 is the parent standard. There are child sector standards, 511 for the process industry, 62061 for machine safeguarding. There's one for medical devices. There's one for the defense industry. There's one for railroads. There's automotive functional safety, all that fun stuff, right? So this is the parent requirement, and it has a nice little document here. And I've added to it, that's why it says modified. So this is figure 8 and 508. And you'll see that you're supposed to be collecting data from maintenance reports. And I gave some examples of bullets of what maintenance data might be.
Would that be part 2 of 508, Mike? Or?
Yeah, I think it's in part 2.
Part 2, yeah.
I was sitting here thinking that same question when you just asked. So
it would make sense that it's in part 2, yeah.
Yeah, so you can see that I was like, oh, well, what maintenance data? Well, did I test it? Was it on time? Yes. Was it late? Did it pass, fail? If it failed, let's get some data about what failed and why. And let's figure out what's a safe failure, which reduces trip, we don't care. And the big ones were laser focus on it was a dangerous failure. And we could even start getting into mean time to repair. How long are we running with, the no brakes on the car? What we know the brakes aren't there and we're choosing to continue to run. Let's get line of sight on that. I'm all supposed to be getting data from ops. And again, I put some bullets there. So what if I have bad quality on a field device, less than 4 or greater than 20 milliamps, we're bypassing stuff all the time, or we have excessive demands. Playing Russian roulette with demands, we've assumed, once every 10 years in the LOPA, and we're having something once a month. All of that stuff is fed in, that little decision thing, and you'll see type of event with engineering judgment on event. That is verbatim 508 lingo. And then you're supposed to take that performance data derived on actual operation, that is exactly 508 lingo, and you're supposed to compare it to what you assumed. What do we assume in the LOPA? What do we assume in your SIL calcs? And if we have a risk gap now, you're supposed to revise your risk analysis and potentially do a modification request. So this entire standard from day one has always been intended to be make assumptions on what we think is going to happen, collect data on the real world, and where you have assumption busts or disconnects, make modifications. You'll see that it wants, if it is a systematic failure, they want you to go straight to make modifications to eliminate that. We'll talk more about systematic here as we get into it. And oh, by the way, that top little box, you're supposed to be collecting a database on all failures and all demands, so you have line of sight of what's happening in the world. So this is 508. So 508 wants you to collect data on the maintenance, wants to collect data on what's happening in ops, compare it to your assumed performance in the LOPA, assumed performance in SIL calcs, and if there's a risk gap, do something about it. This is not, and 511 has all the same stuff. It's just in words, and it's scattered in Clause 5 under Management of Functional Safety. It's scattered in some of the ops and maintenance sections on all this. So here's one nice picture. I think the next slide kind of simplifies it a little bit. This is just showing top down. Yellow stuff is your new capital project, right? I do a PHA, I do a LOPA. I'm doing some barrier design and reliability modeling. I've got requirements spec, cause and effect test plans. That's all stuff you're making on your project. That IMP, that's implementation. So it kind of says we've got to get this stuff scheduled in a mechanical integrity program, so we test it per what we assumed. And then the next 30 years is all these O&M requirements. I'm supposed to be looking at demands and bypassing and actual failures and testing on time. And that last little box is modifications. There needs to be revision control. And if you look on the right-hand side of all that, you'll see data coming out of O&M being fed back in. So the intention for this is closed loop for safety. So just like a PID loop where we've got a sensor and a final element, we're trying to maintain a set point. Think about it that way. We have a risk target. We've determined that we think we're in a happy spot under a risk matrix. And if I have excessive demands and it's bad enough, I might move out of that happy box on my risk matrix. You can have a risk gap. And now I should make corrections to get me back to where the risk is, back to being deemed acceptable to the business. So all that O&M stuff, that's where the heart and soul comes in. You heard me say earlier, the world's most perfect SIL calc to 8 significant digits, and the world's most perfect SRS with every shall addressed and I's dotted and T's crossed and perfect grammar sitting on a shelf behind John on his desk that never makes it out into the plant. That is not making you safer, right? I need that feedback loop. I need to be using it in the business to identify those invisible things that are invisible today, make them visible, make them actionable. And all of a sudden, functional safety has true benefit to the business.
So the next slide we had was field device selection.
The topic here is, should I buy certified stuff? That was the thing. And you can see in the standard, there's a decision tree. Should I use certified or prior use? So let's go the certified route to the right. If I want to use certified devices, 61511 second edition says fantastic. If you're going to do that, you're going to get a device that's been certified by 508, Part 2 and Part 3 by the OEM. And there are field devices and logic solvers available in the marketplace for you. That standard is not applicable for end users. End users are going to go to the left-hand side. But here's your first giant buyer beware thing. The vendor does not know what you're doing with that instrument. So the process interfaces are excluded from their certification. So if you've got this in nasty, dirty, fouling service, or you're putting it in, I live in Alaska, so it's seeing minus 70 degrees Fahrenheit in the winter, or it's in the Middle East in Saudi where it sees 152 degrees in the shade. None of that stuff is in the sticker. So you've got to recognize that right off the bat. Can I use this for all field devices? Can I buy every field device known to man with a SIL sticker? And the answer is no. A lot of your final elements don't have SIL stickers. If I'm looking for, last time I looked at this, there might be something out there, but motors, motor contactors, motor starters. Siemens had a SIL 3 rated motor starter for, I think, 25 horsepower. Beyond that, nothing existed. So what do I do when I have a 200 horsepower motor? How am I dealing with that? What if I've got a 30-inch ball valve that's been installed and works great in my facility, but we don't have a sticker? We ripping that out? No. So there's a go to the left, and we'll talk about that in a second. But pressures, levels, temperatures, flows, sensor-wise, all those can come with a SIL sticker, and I can use those. And that comes down to that bottom bucket, about 11.9.3 that we'll talk about in a second. So if I go prior use, I'm at an existing facility
Yeah.
and I want to go prior use. The reason most people don't go this route is like, well, I don't have any data, so I can't use this route. Well, so is it really saying rip out every instrument I have and go to the one to the right? The answer is no, that's not practical. And we'll talk more about this, but to do prior use, you're supposed to gather evidence that these things are working. Systematic faults, systematic errors, systematic capability is low. We feel good about these things. You should be looking at the full device boundary. So all those process interfaces that are excluded on the certification route should be in your review. And you need to make sure you get enough volume of data to make sound business decisions on, so statistically valid. And at the end of the day, we need to track this stuff. So most folks that are end users on the call probably have an approved vendors list for devices. That's all it's saying. Manage this kit for instruments that you're leading on to prevent fatalities, keep product in the pipe, manage an approved vendors list program. It's not asking a whole lot more than that. And I would contend if I'm at an existing site and I've got 15,000 instruments on my safety critical equipment list, I'm not ripping anything out. I'm not putting new stuff in here for a variety of reasons and going the route to the right. I'm going to go to the route to the left. I'm going to call it prior use in progress.
Yeah.
I don't have data today. We'll start collecting it tomorrow. And in short order, depending on device quantities, we'll have statistically valid data and we can go. And you'll see that I can use that for every field device. I can use that for energized to trip. I can use that for de-energized to trip. Most of the certification stuff doesn't handle energized to trip stuff. There is no data. You're on your own. You'd have to go this route anyway. And that last little box down there says, regardless of where you started with your failure rate, whether I assume a generic because I don't have any data in my prior use in progress, or I have an assumed number from the OEM on a SIL sticker, that last box says your failure rate data should be credible, traceable, documented, justified, based on field feedback from similar devices in a similar operating environment.
Yeah.
How's that stuff working in your world? If I've got this certified thing that says fails once every 100 years with no fouling taps or no installed in a high heat and humidity and salt environment on a Caribbean island, and we see failure rates, once every 10 years, well, that thing's not doing what I need it to do in my application, how I use it, how I maintain it, how it's installed.
Yeah.
I need to identify that, find that, and be able to fix it. So certification is a starting point, is all it is.
Yeah. So as a kind of summary, you end up at this point, whether you go this route or this route. Yeah.
And what I see, especially on capital projects, the
Yeah.
EPCs somehow think that it somehow absolves them of liability. They don't have to think. Somebody else
And
gave
it
them the
doesn't.
number,
Yeah.
so they want to go that certified route across the board. Plus,
Yeah.
some of the marketing engines are absolutely phenomenal for these OEMs. Like, I'm not bashing Emerson. The Emerson marketing engine is phenomenal, is amazing.
Yeah.
They're going to go zip over to the EPC, buy them some pizza on a lunch alert in the States, and next you know, everything you got is certified pressure, temperature, level, flow. You got DVC 6000s on every valve. Those guys are awesome. But at the end of the day, do you really realize that that's just a starting point? I still need my data.
Yeah. And let's not pick on any single manufacturer, but I know you're not. You're not doing.
I'm joking about that. Their marketing engine is phenomenal, and their stuff is good. So it's not a negative.
Oh yeah, it's good. It's good kit. But the point is, it doesn't end with SIL certification. Even if you go that route, it doesn't end. Yeah, it doesn't end there.
They're assuming something on your behalf. They don't know what you're doing with it.
Yeah. And
you could be better than what they think, or you could be worse than what they think.
Yeah.
And that previous slide for closed loop for safety, and the entire intention of the standard is do I have a risk gap with my stuff, how I'm running it?
Yeah.
And if I do, go fix it. And if I can identify that before a near miss or a loss of containment event, well, the crowd goes wild. That's what we want, right? We want to find these things through our mechanical integrity room and fix them, instead of finding it on an instant investigation. So, yeah.
Okay, let's. We're still on question 1, so I'm keen to keep moving.
This is just the 11.9.3 again. I won't read the words, but what you see here is you assume an initial failure rate library. That could be generics, because I'm prior use in progress. I don't have any data today, but I'm going to do some generics, or it could be certified. I go collect some data. I make sure I'm getting consistent pass, fail, safe and dangerous coming out of the testing program. And I analyze the data when we have significant time in service, calculate lambdas, and either go tell your boss we can extend testing and save some money. Look, the data says so. Now you're a hero, or you're going to find some risk gaps that you didn't know about. You're going to go show that to management. You're a hero again because we were driving the car with no airbags and nobody knew it, or we had no brakes and nobody knew it. Now we can go fix this before a loss and containment event. And so there's nothing bad that's going to come out of this data analysis. You still get the little plaque and award on your desk potentially for saving money or reducing risk, and that's what the standard's asking you to do. So it's just whatever reason it's perceived as hard, and the certification is perceived as easy. So
because it kind of it absolves a part of the responsibility, but it's not the end of the story. That's a key message.
Yes.
Okay, I'm going to move us on to question 2. So, certified devices are tested against a manufacturer's design basis. Prior use evaluates install performance. How should users be addressing a situation where a certified device is installed in a process environment harsher than the factory test conditions? So, you've kind of introduced that a little bit, but now we're in a kind of a specific situation now.
Yeah. So if anybody knows Paul Gruen, Paul wrote a bunch of books. He used to work for me way back when. Interesting fellow.
He used to work for me way back when as well at some point.
Yeah. So Paul had a little saying. He used to teach EC50 all the time, and he wrote some books on it. He was actually, when Paul retired, he tapped me to be co-chair of the SIL committee. So I replaced Paul, is what ended up happening. So he had a little say is that, statistics are just like spies. You interrogate them long enough, they'll tell you anything you want.
Yeah.
Well, that's a little bit what you got going on here with these datas. So think about what's happening. John and I get a company. We're going to go certify widgets. That's our new charter in life. We're going to get a purchase order from the Acme transmitter company that makes certified devices, and they want their stuff to be the best thing since sliced bread. And we do the initial analysis and it comes out their stuff isn't good. They're like, well, that's unacceptable. I need it to be better. So there's assumption we can begin to do to slice and dice the failure rates and how we do the FMA EDAs, and we can exclude stuff. And lo and behold, you're the best thing since sliced bread. You're SIL 2 capable, you're SIL 3 capable. Isn't this great and wonderful? And you get a sticker and they get their marketing bang for the buck. And we're not wrong with what we produced, but we've made some assumptions that may not be obvious. And so one of those things right off the bat is process fluids. The certifications is your transmitter. This is the transmitter. It's sitting on my desk here. That's what got certified. It does not have nasty, fouling, corrosive, plugging service in there. It does not have extreme high temperatures where that might, have electronics and parts age faster than normal. It's not going to have extreme cold conditions. It's sitting here perfectly wonderful on my desk. So all of that stuff has been excluded. And there's also, and I'm going to touch this more on systematic. So a systematic failure is one that says, I did something, John was supposed to check it. Let's just do something simple. I screwed up the units. Instead of, I did my math wrong. I've done the units wrong. We're going to launch our rocket. It's going to go into the sun because I screwed up the math. And John was supposed to check it and he missed it. And the next guy was supposed to approve it and he missed it. And lo and behold, our rocket gets burned up in the sun.
I think that's
all the systematic error.
I think that's a real accident somewhere. Did Ariane space rocket?
Yeah, it has happened before. So this is training and awareness, right? We teach me to do better on my math, and John's going to pay more attention as the checker, and we're going to have the approver guy do a spot check somehow. And with training, awareness, and work processes, we eliminate these.
Yeah.
But systematic is gray. And by that, I mean, we're going to talk about valves in a second. But if we have a transmitter in fouling service and it plugs once every 10 years, the taps plug once every 10 years. If I'm not going to do anything about it, and we're going to continue to leave that exact installation, that exact technology in there, it's not a systematic error. We haven't eliminated it from the business. those failures need to be included in your bucket to calculate dangerous undetected failures.
Yeah.
If we're going to change its installation, we're going to change the technology, and we'll never have plug taps ever occur again, then it's truly systematic. The OEMs assume a lot of systematic stuff on their behalf to make Lambda DU tiny. They also will put diagnostics in, and I jokingly say, I can build you a SIL 3 system that trips once a day. Don't you want one? So just because it's SIL rated doesn't mean you're going to want to install it in the plant. Doesn't mean it's not going to be bypassed inside a month. But if I put diagnostics and give you a when in doubt trip me design, I can have a simplex design with no redundancy, with Lambda DU being really, really tiny, and it may not be something you want to own. All this is hiding in that certification process and may not be obvious to you as an end user.
Yeah.
So this is, I think, where we're at, right? So what I just said is I buy a certified widget. Now I just made it hard, because instead of just taking that number and taking that the failure rates out of the FMEDA, out of the report, shoving it into my SIL calc engine, calling it good, Mike just told me I need to downgrade this math, because this is the best thing since sliced bread. This is the best performance it's ever going to have, and I need to downgrade it. Well, there's one OEM I know that does that, has the capability, but you really need to dig into your certification engine and who's doing it, and do they include this in their devices? Is there something, a mechanism in there that says, what if I'm in dirty service? What if I install it in a high heat environment in the Middle East? What if I install it in Alaska, and I need to downgrade that failure rate because it's too good to be true?
Yeah. So you're saying that any modeling you should do should include a service modifier.
You need some type of modifier. It needs to be across the board. If you start with certified, you've got to decide this.
Yeah.
So there's a couple OEMs on the planet that actually have data, have prior use. There's one global oil and gas company that's got millions and millions and millions of hours of data, probably 20 plus years worth of data.
Yeah.
And I was talking to those guys the other day. We were debating Gaussian versus Bayesian math and prior use calcs and stuff like that.
Sounds exciting.
And I asked them point blank, I said, how does your data set compare to, prior use data? And they said, what do you mean? I said, well, let's just use ARITA. ARITA's got data for the North Sea, got lots of it. It's a big giant database. Are you better than or worse than them? They said, well, we're equivalent or slightly better. So we feel really good about our data set. All right, well, that's fantastic. I said, well, how do you feel about certifieds? There were 6 of these SMEs on the call. They all laughed. Some of them were actually belly laughing and said, too good to be true. Can't use the certified stuff.
Right.
So this is
the certified data.
Is the
yeah.
Certified data. Yep. Yeah. So when they take their prior use numbers, because theirs is including the process service and the process fluids and the environmental issues all in their numbers, and you don't have that in the certifieds are over predicting goodness of the device.
Yeah.
And so this whole thing that certifieds are required, this was, I was jokingly looking at it, it's like, well, from an OEM standpoint, it's fantastic, right? They can sell more widgets.
Yeah.
Very simple message. If it's used in safety,
the manufacturer of the widget is happy all day. Yeah.
Yep. So it's a simpler sales message. They can double their sales, get you a bi-regular transmitter, but a certified transmitter. The customer's just going to lean on it. If it's certified, it must be good, right? And think that somehow that helps them from a legal positioning. And now there is as SIL versions change, you've got to keep up with the Joneses on this stuff. So there's maybe a recurring revenue stream. And over time, where you just said earlier that 508 doesn't require this, you'll see that, it's one way, then it becomes the normal way. Go back to that slide real quick on the
sorry, I was just skipping ahead to see what was next.
I want to. So certification becomes one way, and it's kind of like, if you hear it over and over again, all of a sudden it becomes best practice, then it becomes expected, and now here we are, it's required. We've got to do this. And I think the general user community doesn't realize that it is potentially, depending on your certifier, too good to be true data that needs to be downgraded. So there's the buyer beware, if you will, out of all this.
So the next, it seems to be, okay. Sorry. Yeah, the next one was about failure classification of a valve.
Yeah, this is when I say pass and fail.
Yeah.
So this gets into valves. So I'm going to talk about valves. I'm going to talk about systematic errors on a valve. So if we just look at a valve, there's a little decision tree on the left. Oversimplistically, it just needs to close fast enough, right? In your safety requirement spec, you've done some process safety time. You've then allocated response time to the valve. And let's say the valve's got to close in 10 seconds. And if we de-energize its output and it closes in 8 seconds, the crowd goes wild. We're all happy. Woohoo! It passes.
Yeah.
If it's longer than 10 seconds, it's a dangerous undetected failure because we found it through testing. If it didn't change state at all, it's a dangerous failure. I put that little thing to the right, and I don't like how that showed up on the slides, but all right, fine.
Yeah, don't
This
worry.
gets into leakage, seat leakage. Not every valve needs tight shut off. You might buy it as tight shut off, but is there a safety connotation on seat leakage? It's the exception on the norm. So I didn't put it in here, but basically if there is a safety connotation on a valve and you set pass fail criteria for seat leakage, if we supposed to have less than 30 bubbles per minute and we had 20, great, it passed. If it's longer than that, it's failed. Go to the next slide, I think, John. So there's simple pass fail stuff on a valve. Now, Namor has a white paper. They actually have a standard on a document on failure classification. This tiny print thing, if anybody wants it, read, holler and I can send it to you. This is a position paper on valves. And
Okay.
what you'll see here is
we're not expected to read that here. So
no,
you're just saying there's a paper
if anybody
backing
wants
this.
it,
There's a paper backing this up.
If anybody wants it, reach out to John and we'll send you the link. But this is the heart and soul of certification and what is systematic, what is not, and how do I game the numbers. If you look at this, what this is saying is if the valve closed slowly, it's my fault. I didn't specify the right torque. I didn't put enough instrument air pressure on it to make it go fast enough. If it leaks, it's my fault. I specified the wrong seat requirements. If it corrodes, erodes, I spec the wrong materials of construction. So if you look at it, the more is saying in this white paper, all failures associated with the valves, and I do failures in years because I find it easier, 114 years. If I have 114 valves, I see one failure per year for failure rates. They then started parsing that data set to say, well, I only want things related to the valve proper, and I want to exclude some of those things. And all of a sudden, I'm an order of magnitude better when they parse the data. Mm-hmm. Now, 1,142 valves in my facility. Only one of these is failing dangerous undetected a year. And when I put the systematic error issue on it, saying it's all screw ups on valve selection, a valve never fails. We have a failure once every 4,566 valves per year. And that might be academically true, but it's not what needs to happen in the facility.
Right.
If the valve doesn't close, it failed. If the valve fails a leak test, it failed. I don't really care why. And if I'm not going to change material construction, I'm not going to change my instrumenter design, I'm not going to change the valve torque, and I'm going to continue to put that same valve in, that's got to go in my numbers.
Yeah.
So in this scenario where it says basically there are no random hardware failures with a valve, none. Why even bother including them in the calc? If you're putting those 25 fits in, it's going to tell you, and you did some math, well, I can do a full stroke test on this valve once every 15 years or something. Isn't this great?
Yeah.
And if I'm a refinery fill gas service, and if I'm not doing a full stroke test in a year, seats are going to get crapped up, and the valve's not going to be able to close. And I just looked at the math without thinking it through, and I've actually made the facility less safe.
Yeah.
This systematic error thing is one way that failures are being excluded out of those stickers, and you may not realize it if you don't think about it. And it really comes down to if the vendor got the wrong resistor on the printed circuit board, yeah, that's real, that needs to be fixed. But this is instrument engineering and how you're applying stuff that's being excluded, if you will. So buyer beware.
Okay, thanks, Mike. I'm going to try and get on to question 3. Whether we'll get to 4 or not, I don't know. But I'd like to leave at least kind of 10 minutes. So we've got a kind of 5 minutes on this topic. Right.
Let's pound through this.
So this is quite an important one. Is prior use simply too difficult to justify compared to sourcing manufacturer devices? Is it too big a burden for the average end user to manage?
And I would contend
that's a perception.
No. Yep. Show me the next slide. So here, this is in ISA TR 84.04. It's on device selection. And the little green boxes basically say, if I'm going to go certified devices, I should never put a brand new technology, a new device in my plant, guarding its fatalities without trying it first.
Yeah.
There needs to be a beta period. We need operating experience. And then if I go over to B and I'm using prior use or general purpose stuff, I need operating experience. And it doesn't tell you how long that is. It's just basically saying I need operating experience on any instrument I'm going to put the guard against fatalities.
In both cases, yeah.
And in both cases. And if I'm going to lean on a certified stuff, I need less time. If I'm going to do a non-certified device, I need more time. But it says I should never, ever, ever be installing this. So now we have a whole chicken and the egg. I don't have certified devices on my site. I don't have prior use devices on my site. I'm not allowed to put them in service. What do I do?
Yeah.
Well, it's approved vendors list, right? New technology gets tried out. You decide if it's going to work or not. If it does work, then you roll it out wider. You're not ripping out stuff you've had for 20 years if there's no obvious known issues. Let's go to the next slide and we'll talk through this one. What this is saying is instrument engineering. So that green eye, it may not be obvious. You could be an instrument engineer, you could be an SIS champion, you could be a reliability engineer. There's one company that I work with, they call them I&PS engineers. And if you say the I is capital, bold, bigger font stands out, it's instrument. Instrument engineering is the most important part. Protective system is an aside. Here's 3 use cases, war studies. There was an acid gas knockout drum for a Klaus unit, SIL committee folks. Ooh, it was a level displacer, been there for 20 years, works fantastic. We don't have failure rate data. They ripped it out, put in a certified SIL 2 rated transmitter. They did DP with some capillary and some pancake flanges. Instrument techs found the taps plug 3 months later, ripped it out, put the displacer back in, said, I guess we need to figure out what failure rate data is for the displacer. Another customer had a bunch of positive displacement pumps, 274 of them to be exact. They did not have relief valves at the discharge of these pumps because they made paint. And if you had red paint and it collected in that little dead space under the relief valve, well, then next time you ran blue paint through there, it screwed up their product quality. So no nooks and crannies and dead spaces. So they were doing high pressure close a valve. Well, they had a pressure switch to a relay killing the pump. They did some math on it. Oh, we need certified stuff. So they bought those switches that use 4 to 20s, where it's between a 4 and 20 and a trip is 16 milliamps, one way or the other. And they put 274 of them in an outage, and they began testing them. They were supposed to trip at 150 PSIG. At 250 PSIG, they were not tripping. So they had to stop their outage, rip all those brand new fangled SIL 2 certified stuff in that had infant mortality in them and go back to their switches. So big cost issues because they didn't try before they rolled them out. This is a more products thing. This last one, John. Remember the more products red transmitter, the XTC 345, I think it was?
345, yeah.
Yeah, so in that thing, to get SIL 2 rated, there was diagnostics built into it.
Yeah.
And there was a max rate of change. And said, in the real world, if the pressure changed faster than this, the transmitter must be broke. And so this was installed on an ethylene reactor. They had a blue transmitter. If you think of the baby blue, you'll know what vendor that is. And they had the red one. And they were side by side, and they kick off the reaction. And lo and behold, the red one trips. And what's going on? The blue one says, I'm happy. The red one trips. They start the reaction up again. Same thing happens. It was a max rate of change assumption. So this was a safe failure, but again, infant mortality issues where the diagnostics, when in doubt, trip me to get me SIL 2 instead of, it was resulting in this reaction's going the pressure's rising too fast. And so this is examples of 3 different wrong. 1, we used stuff we didn't have any prior use on, and 2, instrument engineering bust potentially on the acid gas knockout drum, all resulting in cost, waste, and not being safe like we anticipated.
Yeah.
Jump on the war stories. If you want to add an instrument, it goes through the approved vendors list. If you want to blackball an instrument, through the approved vendors list.
The point here is your approved vendor list is really important for a prior use approach.
Yep.
Yeah.
This is the last little thing. There's a SINTEF report on this as well. There's a quick way to calculate time in service. What this is showing, if I have 500 pressure transmitters and my assumed failure rate is once every 150 years to failure.
Yeah.
There's a calculation in years, and it says how many widgets do you have and how many years. And this one said if I got 500 devices, I have statistically valid data in a year. So after 1 year of testing, let's look at what the failure rates are. Let's calculate a lambda and see if we can extend testing.
So let's just get this right. So this is if you've got 500 devices, it's going to take you 1 year to collect enough data.
I need 150 devices to get statistically valid data.
Right. Okay.
With this assumed starting point lambda. Whether that's a certified number or an assumed number, it's a quick little way to figure out when you have enough data to go calculate a priority assignment.
Okay. So if you only had 50 units on site, it's going to take you 3 years to.
3 years, right?
Yeah.
And so if you aggregate this from multiple sites, you're going to have statistically valid data in a year for almost everything you've got.
Right.
Especially if you're saying anything that's safety critical equipment, not just the safety functions. So it's straightforward.
I think it's quite important because I hadn't really realized myself until we talked about it recently that you don't need quite as much data as you think to get something statistically significant.
If your failure rates are tiny, like for a logic solver or maybe even motor starters, it does take a large count.
Yeah.
And it might be the violation of laws of physics. But for typical field devices,
we're talking
all
field
your sensors,
devices,
all your valves, it's going to be easy to get statistically valid data.
Yeah. There's quite a few questions come in, so I'm not sure we're going to get through. I'm sure we're not going to get through all of them, but we'll try and answer them all after the presentation. Certified or not, don't you still need to record your failure and demand rates once you've gained operating experience?
100% yes.
Yes, 100%. I think you actually said that. Possibly you hadn't said it at that point, but so that's the answer to that is absolutely, and in fact, that's really important.
Assume versus actual.
Yeah. So we want the actual so we can compare it with the assumed. Okay, let's come up with another one. Is this where FSA4 are supposed to cover this analysis? Okay, yeah. I'll let you answer what you think.
So I would say and what I would do under the approved vendors list is a series of checks and balances. Mm-hmm. Somebody's day job should be removing risk from the business, excessive bypassing, excessive demands, excessive failure rates. And the stage 4 FSA should be, are we doing what we're doing? Are we effective at removing risk from the business? We shouldn't be doing a stage 4 FSA to find out we're not doing anything with this data. Somebody's job.
I was kind of going to say the same thing there.
And fixing it. So yes, the FSA should be covering it, but you should have somebody in your day job wanting to do this.
Absolutely, yeah. And I do a lot of FSAs, especially in oil and gas industry, and I think it's very common to find that companies are not collecting the data they should be, and so the FSA4 finding typically comes up with you're not doing enough, and you need to start doing it. Are there good commercial tools that automate the data collection process and analysis that you can suggest? Mike?
I'm trying to be non-commercial, but
be a bit commercial. That's what we're here for.
Yeah, so I can help you with that. Yes, there are tools that do that. I make one of those. So trying to make this simple. So there's an expert system to make the deliverables and a fast way to play what if on lambdas, calculate the lambdas, all that fun stuff. So
yeah. So in short, there are tools available that can help you with the process. You still have to implement a process though to have some general or generic rules of thumb that you suggest for service modifiers for common setups.
Most of my world is all brownfield, right? That's what I work on. I've not been a mega capital project guy. So I generally am starting out with a generic. There are multiple generic sources available. You can go through, and even from an FSA standpoint, everybody should know what a range of the typical failure rate on a transmitter is. Because at the S84 committee, we're seeing stickers where a transmitter, I'll throw a number out. If it should be at roughly a 1 to 100 years, a failure rate of 100 years per device, type thing, and you're seeing 10,000 years or 1 million years or craziness, I don't have a rule of thumb for you.
Okay, thanks, Mike. We're getting really near the end of our session. We've got more questions here than we can possibly answer, but I'm going to finish with one here, which is not a question, but a comment, but I'm going to highlight it anyway from Hugh. Not so much a
Yeah.
question, but what I learned the hard way: collecting random failure rate data during operation. Tell the technician to report the as found condition and then fix. Absolutely.
Yeah, war story for me is we had a gas plant that would, ran the entire north slope of Alaska. If the gas plant went down, the lights went off, everything went down, all production, and every user was using it. And so we only could take it down every 5 years. And it's 30 years old, you would expect to see failures. And they didn't report any failures ever. So you'd have to go meet with them, you'd have to talk to them. They thought reporting failures we're best in class maintenance facility.
Yeah.
We don't have failures. And it's like, well, wait a minute. What are you fixing all the time? What if I got you money? What if we could eliminate this and not have you, go rod the taps out all the time or find the failures? They didn't realize that. So basically they're keeping two sets of books.
Yeah.
Um, and they said, well, it was stupid. We had two PMs, one to calibrate the instrument, run the proof test. I'm not going to set up on it twice. So we calibrated, fixed all the problems, ran the proof test. There were no failures. It worked perfectly. They fixed everything under the calibration side, worked like a champ, still have failure rates still hidden in there, not getting out, not removing them from the business because they didn't want the perception of having a poor maintenance program. So you've got to work on that massively.
Yeah.
Yeah.
But I like the comment, Hugh, so thank you for that, because I've come across it as well. I'm going to call the session to a close.